So to find those roots, if it's a quadratic, we can use the x method. We could use quadratic formula. If we are given polynomials in factored form, you take each factor, set it equal to 0, and solve. So it's super nice when it's in factored form because it's really easy to solve, okay? If you are given a graph, you look at, I'm going to zoom this in a little bit, where the graph touches or crosses the x-axis. So in this case, right, so this crosses the x-axis. So our zeros are at -6, x equals -4, and then it goes through the origin, so also at 0, okay? Also, just to remember from yesterday, what do you think the degree of this function is? Even or odd?
It's not even.
Even, because why?
Positive.
Because the axis is both
Going up. They're even it's positive because they're both going up, so good memory. Okay, so this kind of goes into when we are doing division. If you are given one factor, you can find the others using long or synthetic division. Okay, so for example, it says find all solutions to f of x equals 3x to the third plus 7x squared minus 6x minus 10. What degree is this polynomial? Third. How many possible zeros could it have? 3. We are given one factor. So there are 2 other factors that are possible here that we need to find. So what we're going to do is we want this to get to quadratic because then we can just factor a quadratic with our x method. So we are going to use division to take this factor x plus 1 and divide 3x to the third blah 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 by that. So because we have a coefficient of 1 in our binomial, we can use synthetic division. Take the opposite of the sign in the binomial. And then we put our coefficients. 3, 7, -6, -10. They told us it's a factor, so we should get a remainder of 0. But we got to do the math anyway because we're going to need exact values. So bring down the 3. -1 times 3 is -3. 7 minus 3 is 4. -1 times 4 is -4. So -10, 10. Good. Okay. So that's good. So it is a factor. They told us it was. So hopefully it works. Now, what is the degree of this answer? No. 1 less. 1 less than our original. So this, if I write it out, the answer is 3x squared plus 4x minus 10. Now I have a quadratic. How do I solve a quadratic? Try to x method it. Oh wait, not -10, -30. And 4. Is it going to factor?
Probably not.
No, it doesn't.
It's gotta be cube.
So, yeah, quad form. If you can't factor, you use quadratic formula to solve for your roots, which is sad, but like it happens. So like we have to do it. So A, let's write down, we've got A equals 3, B equals 4, and C equals -10. So we have to do quadratic formula because it wouldn't factor. Okay, X is equal to -b plus or minus the square root b squared minus 4ac over 2a. Okay, there's our setup. Set up our quad form. And then we're just going to simplify. So -4 plus or minus 4 squared is 16, and then 4 times 3 times -10 is 120. And it'll be positive. So 16 plus 120.
136.
Yep. Over 6. Remember, we always have to check that this radicand doesn't have any perfect square factors because we'd have to simplify it. It does. It's 4 and 34. So 4 simplifies. What is the square root of 4? Good.
-4 plus or minus 2, or 2 square root.
2 root 34 over 6. Right? Everything outside the root can be divided by 2. So we have to do that. You cannot touch what's under the root, but everything outside can be simplified. So we get -4 plus, we just can call it, we don't need to say 1. Square root of 34 over 3, not -4, -2 because we divided by 2. Yes.
Plus or minus.
Plus or minus. I'm going to write them separately because I just want everyone to remember that that's 2 different roots. So we have this root. We have this root. We said there could be 3 roots because it was cubic. What's my third root? What's my third root? X plus 1. Don't forget about that one. So we take that, set equal to 0. My third root will be at a whole number, at x equals -1. Okay, so you can factor polynomials also by grouping, especially when we have higher order polynomials, like to the 4th, to the 5th, etc. What we do is we arrange the terms in groups that have a common expression, factor out the GCF, and then write your factors as products of the GCF and the common expression. Once you have it factored, as we always do, we set each factor equal to 0 and solve for x. So here's a couple examples of factoring by grouping. So for this, we could group these two together because they have a common factor of 8x squared. So I could pull out an 8x squared from both of those terms, which would leave me with 8, no, not 8x, it would just be x. If I pull out 8x squared, x minus 8. And then from this one, I could pull out a 1 so that I have that same GCF, because then I'm going to use this to set up my factored form. So when I do factored form, this becomes one of my factors, 8x squared plus 1. And then this becomes my other factor. I only put it one time. So that's my factored form. And then to solve, I set each of these equal to 0 and solve. So I'll have one that's 8x squared plus 1 equals 0. And then my other one will be x minus 8 equals 0. So to solve this one, first I subtract 1 from both sides, which gives me 8x squared equals -1. Then I divide by 8, and I get that x squared equals -1/8. I take the square root of both sides to cancel that squared, and when I insert my own square root to solve, I have to account for both the positive and negative possibility. So that I get that x equals plus or minus the square root of -1/8, but I can't leave the negative underneath the radicand. I have to pull that out and say plus or minus I root 1/8. So those are two of my roots, plus I root 1/8 and minus I root 1/8. The other root is going to be when I have my x minus 8 set equal to 0. So my third root is x equals 8. The only root that I can graph is going to be this one because we cannot graph imaginary numbers. Number 2, let's factor this by grouping. So I'm going to put these ones together, and I'm going to put these ones together. So out of 21x cubed minus 84x squared, I can pull out 21x squared as a common factor, which would leave me with x minus 4. And then out of my other one, I could factor 15 out of both, x minus 4. So then my first set is going to be 21x squared plus 15. And then my other factor will be x minus 4. So then I set each of these equal to 0. 21x squared plus 15 equals 0. And x minus 4 equals 0. And that's going to be my roots. So if I subtract 15 from both sides, I'm going to solve for x. So I get 21x squared equals -15. Divide by 21. And then I get x squared equals -15 over 21. Those are both divisible by 3. -5 over 7. And then my square root, take plus minus. So I get x equals plus or minus, pull out this negative sign, I root 5/7. And then my other one, if I set this one equal to 0 and solve, add 4 to both sides, you get that x equals 4. So those are my roots. The only one that I could actually graph is this because it's not imaginary. If a polynomial is a trinomial and quadratic in form, meaning that it either has exponents of 2, 1, exponent of 2, exponent of 1, exponent of 0, like a constant. That's quadratic in form. This is also quadratic in form. So if we have differences here of 2, or we divide it in half is actually what it is. So first exponent divided in half. So you're typically going to see squared to the first in a constant, or to the fourth to the second in a constant. When we see that, we can use our x method and factor it like a trinomial. So like a quadratic. So the roots, the only difference is when we have it to the fourth, rather than having x plus something, it'll be x squared plus or minus whatever your constant is after you factored. For example, number 3, we can see that this is quadratic in form because we have x to the fourth, and then our next term is half a degree, like a degree cut in half smaller. So half of 4 is 2. So we'd use our x method, 2 on the top, 3 on the bottom. Our two factors are 2 and 1, which gives us, because we're doing to the fourth, our binomial will be x squared plus 2 and x squared plus 1. And then we just set equal to 0 and solve. Whoops. Subtract 2 from both sides. X squared equals -2. Square root both sides. Don't forget plus minus. So x equals plus or minus, pull out this negative sign, I root 2. And then same thing over here, move to the 1 over, which is -1. Square root both sides, plus minus. X equals plus or minus, pull out that negative, I square root of 1. The square root of 1 is just 1. So we don't have to say that. It would just simplify to this plus or minus the square root of I. Neither one of these we can graph. So this actually does not intercept the axis anywhere, but we still can find the roots. Okay. Number 4, make sure you put this in standard form before you start doing anything. Negative x to the fourth plus 9x squared minus 18. This is quadratic in form, so we can use our x method. On the top would be positive 18, on the bottom -9. So our two factors would be 6 and 3. A was not 1, it was -1, so we need to divide both of these by a -1. So -3, -6. So our two factors, don't forget it was to the fourth, so it'll be x squared minus 6, x squared minus 3. And then set each equal to 0 and solve. So we get x squared equals 6, square root of both sides, plus minus, x equals plus or minus the square root of 6. And move over the 3, x squared equals 3, square root both sides, take plus minus, x equals plus or minus the square root of 3. So those are my 4 roots when we do this factoring quadratic in form. The last thing we need to know about roots of polynomials is that they have different behaviors at the x-axis. So we can determine the behaviors of a root at the x-axis by looking at the factors and exponents of the polynomial when it is in factored form. Okay? So what this looks like, if you look down here, this is what I'm talking about. So when we have factored form, and we'll kind of do this example when we fill in our table. Okay, if your factor has an exponent of 1, which one of these factors in number 5 has an exponent of 1? Yeah, there's an imaginary 1 there. Remember, when we don't have a given exponent, there's an imaginary 1. So this factor, the 0 would happen when x equals -1, right? But there are three things that your graph can be doing at the axis. If you have an exponent of 1, such as this, it will cross the axis, just looking kind of like a line. So it'll be something like this. Okay? It just crosses the axis at that point and keeps going. If we have an exponent of even anything, 2, 4, 6, 8, this factor has an exponent of 2, so it's even. Our 0 would be at x equals -3, but at -3, it's not going to cross because it has an even exponent. It is going to bounce off the x-axis. So what this is going to look like is this. It is essentially the bottom of a parabola. So it's going to look something like this, where it touches the axis, switches directions, and goes the other way. The last possibility is if you have an odd exponent that's not 1. 1's its own thing, but anything else odd. 3, 5, 7, 9, whatever. This 0 would occur at 3, and it's going to, I don't know why we have to call it this, but we do wiggle, which means it will flatten and continue in the same direction. So what it looks like is this. So look at your cross, it just goes straight across. Your wiggle or your bounce changes directions. It's going down, it touches, and it goes back up. What the wiggle looks like is it comes toward the axis, it flattens out as it crosses, and then keeps going. Okay? So it's a much flatter cross of the axis than the cross. Okay?
Is that not just like a cross?
No, because it's not as like linear, it's very flattened out.
So it goes from multiple points?
Yeah, so it still goes through one point. We can graph our function a little bit better. So a couple things that we need to remember. We need to talk about end behavior because that helps us graph. So looking at end behavior when we have factored form. First we figure out the degree, because remember end behavior is even or odd, positive or negative coefficient. We multiply just the leading terms. X times x times x is going to be positive x. So we know that our leading term will be positive. To find the degree, oops, I didn't mean to do that. This should be positive. To find the degree, we add all of the exponents. Don't forget your 1. 1 plus 3 plus 2 is 6, which is even. So what do we know about our end behavior? It's going to be up, up. Okay? So like I would expect that you could graph me a sketch of number 5 because we know the zeros. We know how the function behaves at the zeros. And we know that our end behavior is this. Okay, what did we say? What would happen at x equals -1 because it had an exponent of 1? Cross, wiggle, or bounce? Cross. What's going to happen at x equals 3?
Bounce.
No.
Wiggle.
Wiggle, because it's an odd exponent. And what's going to happen at 3? -3. Bounce. Okay, so what I'm going to do is I'm going to start by plotting those 3 zeros. Here's 1, -1, and then 1 at 3, and then 1 at -3. Right? Okay, at -1, so I know that my end behavior is going to be up, up. So this should be like this. It's going to cross here. That's wrong. That is not, -3 is a bounce. -3, it's going to bounce off here, and then it's going to cross at -1. So this is going to keep going. At some point, it has to turn back up. Well, it's like,
You know it only goes up that high.
you don't. So like, you don't know.
That's why there's an arrow, bro.
Hold on, I'm going to make this bigger. You don't know how high the loops go, and that's fine. I'm not looking at that.
It's not a cross, it's not a bounce.
This is a bounce, yes. At -3, it's a bounce. So we're going to go down, and then it's going to turn up, and then it crosses, and then it's going to sort of flatten out before it keeps going. Okay? The things that I am looking for on your graph, that your arrows are going the right way, that your zeros and the behavior are correct. These things we cannot determine without calculus. So those can be an estimate, which is why it's just a rough sketch. All right, you're going to graph this for me. First of all, we can determine what's happening at every zero. Set each factor equal to 0. This first one, we will have a 0 at x equals 0. What will happen at the axis here? What is the degree of this factor? 1. There's an imaginary 1 out here, so it will cross at 0. All right, this one, set the factor equal to 0, and let's solve to see exactly where it's going to cross, which would be at x equals 4. What's it going to do at the axis? What was the exponent of our original factor? Exponent of 1, what's it going to do? Cross.
Oh, I was looking at the wrong.
Do you see that? This one,
That one's gonna bounce.
set equal to 0, solve, so we'll have a 0 at 2. This was an even exponent, meaning it will bounce at 2.
And then this is gonna be even.
Okay, so yes, so, well, careful. Multiply your first terms. X times negative x times x is going to be odd. So, sorry, it's going to be negative, right? Because we get x times x will be negative. And if we add our exponents, don't forget your imaginary ones. 1 plus 1 plus 2 will be 4. So it's going to be negative even. What are my arrows going to look like on either side?
Up and down.
Nah, negative even. Down, down.
Oh.
Okay? Even they go the same direction because it was negative, it's flipped down. So let's graph our zeros. We've got one here, and one here. So at 0 it crosses, so we know that this arrow's got to be going down. So it's going to cross, or it's going to bounce at 2, so it's going to go here, bounce up, and then we know that this has to keep going down. Okay? So that is what our sketch of our function would look like.